Let's talk about the area of a sector. A sector is like a pizza slice of a circle. It consists of a region bound by two radii and an arc line between the radii. It is a fraction of the area of the entire circle. Okay, so we're just looking for a piece of the circle. The area is proportional to the central angle. In other words, the bigger the central angle, the larger the area. All right, so let's look at some diagrams down here. So if I want to find the area of the entire circle, that's the entire shaded region, I would use the formula pi times the radius squared. But if I want to know just the area of a sector or piece of my circle, I'm going to use the central angle, which is also the measure of the arc, right? Because central angles equal their arc. Okay, so I'm going to use this fraction of the central angle to the entire circle. Remember, the entire circle in degrees is 360. So my formula is going to be the central angle divided by that 360. It's going to be that fraction of the circle times the area of the whole circle. So pi times radius squared. Okay, so this is the formula that we're going to be using. Okay, so let's look at a couple of examples. All right, in this example right here, I have a circle with a radius of 5 and a sector with a central angle of 50. What is the area of the sector? Okay, so in my diagram, I drew a little circle. The radius is 5. And remember, if this is a radius, then so is this, and so is this. Any line segment from the center point all the way to the circle itself is always going to be the same distance. So this would be 5 as well. Okay. My central angle was 50, and so we want to find the area of this shaded region right here. So we're going to use our formula, theta over 360 times our pi r squared. Well, our central angle that they gave us was 50, so we're going to put 50 over 360 times pi times our radius, which is 5 squared. So if I simplify this a little bit, 50 over 360, those are both divisible by 10, so that becomes 5 over 36 times pi times 5 squared, which is 25. Now from here, I can just multiply straight across. 5 times 25, that's 125, divided by my 36 times my pi. At this point, I would go ahead and put this in my calculator. When you put it in your calculator, make sure that you put in 125 divided by 36, hit the enter button, and then multiply it by pi. For the most accurate answer, use the pi button, don't use 3.14. That's going to be a little bit more rounded, so for the most accurate answer, I would use the pi button on my calculator. Anytime you use pi, remember pi is an irrational number and it goes on and on forever. So your answer is going to have to be rounded, which means it's an approximation. So you get approximately 10.91. And I didn't put units on this, like centimeters or inches or miles or whatever. So I just put U for units squared. Area is always squared. Since we're finding the area of a sector, we always have to square the units. Remember, it's two-dimensional, so we have to have a 2 up there for two-dimensional. Okay, let's look at another example. If I have a circle with a radius of 10 and it has a central angle of 293 degrees, what is the area of the sector? Okay, so this is going to be a really large portion of my circle. The radius is 10, and we're looking for this large angle out here, or this large area out here that's shaded in orange. Now I marked the arc 293 degrees, but really the angle is also 290 degrees like they told me in the description. Remember, if it's a central angle, these two equal each other, so it doesn't really matter where you write it, if you write it out here or write it in here. They're the same. Again, I'm going to use the same formula. Theta over 360, or my central arc over 360. In this case, it's 293 divided by 360 times pi r squared. So times my pi, and my radius is 10, so 10 squared. At this point, 293 and 360, those are not, you can't simplify that any at all. They're not divisible by any common factor. So I would go ahead and put that in my calculator. 293 divided by 360. Hit the enter button, and then I would probably just multiply what you get by 100, because 10 squared is 100. Hit enter, and then multiply that times pi. And if you do that correctly, you should get approximately 255.69 units squared. So remember, it's approximation because I had to round it, and you're always going to have to round it. And I usually round it to 2 decimal places if they don't tell me. 3 if they tell me. You know, just look at the instructions and do whatever the instructions tell you to do. But if they tell me nothing, I always go to 2 decimal places. Okay, so let's look at a different type of problem that you might have to encounter. So look at this diagram. I have a circle, and my circle has a radius of 5, but it has this triangle in here, and the only area I want to find is the area that's shaded. So I don't want to find the area of the triangle. I want to find the area of just the shaded portion. Well, pretend the whole thing from A, C, B, and the arc was all shaded in. That would be one big sector. So what we're going to do is to find the area of the shaded region, we're going to find the area of the whole sector, and we're going to subtract the area of the triangle. All right, so let's do a little math. They gave us that this arc is 60 degrees, which means the central angle is also 60 degrees. This from here to here is also 60 degrees. So I'm going to use, to find the area of the sector, I'm going to put 60, because that is, let me get a darker pen, 60 over my 360 times my pi, and they give me a radius here of 5 centimeters, so I'm going to use 5 squared. So times 5 squared. All right, let's simplify this a little bit. 60 will go into 360 6 times, so 60 divided by 60 is 1. 360 divided by 60 is 6, so that simplifies down very nicely. Times my pi, and 5 squared is 25. Now you can simplify it even further by just saying 1 times 25, which is 25, so I get 25 over my 6 times my pi. Now you're ready to go ahead and put it in your calculator. 25 divided by 6, hit the enter button, and then multiply it times pi, and you should get, well, this would be approximate because I'm going to round it. You should get about 13.09, and this is in centimeters, so I'm going to put centimeters squared. Okay, so that's the area of the whole sector, but we need to subtract out the area of the triangle so that we only have left the shaded region. All right, so let's look at the triangle. Remember, the area of a triangle is 1/2 base times height. So if I look at my triangle up here, they give me the altitude as 3, so that's my height, but they don't give me the base. Okay, so I don't know the base. But what I'm going to do is, I know that this is a right angle because altitude is always at a right angle. I'm going to look at just half of this. I'm just going to look at this one triangle right here. Well, if I know that this is 3, and I know that this hypotenuse is 5, then I can use the Pythagorean theorem to find this distance right here, which would be considered my base. So that's what we're going to do. So remember, the Pythagorean theorem is a squared plus b squared, those are your 2 legs, equals c squared, which is your hypotenuse. So we'll call this leg right here 3. We'll call that our A leg. Our B leg would be this leg right here, and we know our C leg is 5 squared, or 5. Okay, so we're going to use this to figure out what the length from A to that altitude is. Okay, that would be half of my entire base. All right, so 3 squared is 9, plus my B squared, and 5 squared is 25, and then subtract 9 from both sides, and you get B squared equals 16. Take the square root of both sides, And when you take the square root, you generally have two answers, a positive and a negative answer. But since we're dealing with measurement, we never have negatives in measurement because you can't have a negative 4 when you're measuring things. So we're only going to consider the positive 4, positive square root of 4, or positive square root of 16, I should say. So, all right, so we know that our base right here is 4. Okay, so now I have enough that I can find the area of this small triangle. So the area of the small triangle is going to be, let me draw a little line here. Okay, so the area of one of the triangles is going to be 1/2 my base, which I just found out is 4, times my height, which is 3. All right, I can do some simple simplification. 2 divided by 2 is 1, and 4 divided by 2 is 2. So on top I have 1 times 2 times 3, and on bottom I just have a 1, and that equals 6. So the area of half of my large triangle, this portion, is 6 centimeters squared. So to get the area of the entire thing, which would be twice as big, I have to say 6 times 2, or 12 centimeters squared. So that's the area of my triangles, or my one triangle. So now let's go back up here. All right, so I want the area of my sector, which we found over here was 13.09 centimeters squared, minus the area of my triangle, which would be 12 centimeters squared. And 13.09 minus 12, well, that would be 1.09 centimeters squared. And then that is the area of just the green shaded region right there. And that's how you do that.